airlock. They'll hand out the necessary bags that are required for the EVA, and then they'll get to work on the nadir side of the space station. They'll be working between the U.S. laboratory and Node 1. They'll be installing an extension cable. This will provide an extension to the power outlet J612. This extension is important because you won't be able to access this port as it is today once the permanent multi-purpose module is installed after this EVA. We'd also want access to this to provide contingency power to Node 3 in the event that it needs to be demated for a contingency EVA. From there, both crew members will head off and start preparing to return the failed pump module to external platform number 2. Tim will begin setting up the space station robotic arm. And off in the distance there on the mobile transporter, you can see the failed pump module that will be returned later in the EVA. Tim will be installing a portable foot restraint on the end of the robotic arm. He'll then ingress that foot restraint and head out to the failed pump module. Meanwhile, Al will be working on the port seated cart, while he'll be retrieving 2 bags that were left outside on the pump module EVAs. He will stow those on a portable foot restraint and then carry that bundle down to external stowage platform 2. This is the permanent home for the pump module, external stowage platform 2, until it's returned on STS-133. Once Al gets back to external stowage platform 2, he'll stow the portable foot restraint and then begin routing the vent tool and vent tool extender that was contained in one of those bags. This will allow them to vent the 10 pounds of ammonia that's currently in the pump module at the beginning of EVA 2. Meanwhile, Tim will have translated up to the mobile transporter and will retrieve the failed pump module. He'll reorient it to get it in the correct orientation to be installed on external stowage platform 2. Here you can see Tim working the neutral buoyancy lab with the mock-up that we train with. The real pump module will weigh about 800 pounds. Tim and I will work together to get this partially installed, at which point they'll remove the adjustable grapple bar and temp stow that. The adjustable grapple bar was used to temporarily stow the pump module on the mobile transporter. They'll then drive 4 bolts to secure the pump module into place, mate the vent tool, and close the thermal blanket over the front face of the pump module. Tim and I will then work together to stow the adjustable grapple bar on the flex hose rotary coupler. This is the permanent stowage location for this tool until it's needed on the later spacewalk. From there, the crew members will begin to tear down the arm. Tim will remove the portable foot restraint and stow it on external stowage platform 2 for use on EVA 2 when Al begins venting of the pump module. And then Al will retrieve the portable foot restraint that he got from the seated cart earlier. Now he'll be playing a bit of a shell game with foot restraints here once he arrives at Z1. He'll stow the foot restraint from the seated cart. He'll then take some time to open 2 thermal blankets that are covering orbital replacement units. By opening the thermal blankets, it will provide Dexter access in case these orbital replacement units need to be changed out robotically by Dexter. He'll then remove a tool stanchion from the portable foot restraint that's going to need to come inside, move it over to the one he just brought up, and he'll retrieve the portable foot restraint that contains a heat shield on the bottom. This heat shield prevents this foot restraint from being installed in some of the worksite interfaces on the outside of space station. This is the last foot restraint that has this heat shield. So I will take it, put it back in the airlock, and between EVAs, they'll remove this heat shield, bring it back out at the beginning of EVA 2. From there, both crew members will head out to the starboard truss near Express Logistics Carrier number 4 that was installed earlier in the mission. There they'll be installing a camera wedge. This wedge will cant the camera and camera stanchion inboard to allow access to the orbital replacement unit site that you see in the background there. Here you can see them removing the camera and stanchion in the neutral buoyancy lab. Once that's removed, Tim will hold the camera steady while Al installs a wedge in the installation location. They'll then reinstall the camera to the wedge, as you see them doing here, and now it'll be in its new configuration canted outboard with plenty of room to stow orbital replacement units on these FRAM sites. At this point, if everything's going well, we think we'll have time to perform a couple of get-aheads. The primary get-ahead that we would like to get accomplished on this flight is installing rail stubs. These stubs will extend the rails that the seated cart and mobile transporter translate on, and will allow them to go to the starboardmost work site. This will allow robotics operations farther outboard on the starboard truss. Here you can see them installing the first section of stub on the nadir side. And there's also a zenith stub that they'll be installing. Now the nadir stub has a built-in stop on it. This stop will prevent the seated cart and mobile transporter from traveling too far outboard off the end of the rails. Currently, there are in place 2 stops that can now be released. This is also a get-ahead task that we hope to get done. There's the tether shuttle stop that prevents an EVA tool from going too far outboard. Here you can see Tim rotating out the tether shuttle stop. And then we also have the mobile transporter stop, or MT stop, that we also plan to stow. This prevents the seated carts or mobile transporter from going too far outboard. With that, both crew members will translate back to the U.S. joint airlock and perform their final task. This is JAXA's message in a bottle. They'll use this to capture the vacuum of space and return it to Earth. Okay, I mentioned on EVA-1 that they will be setting up a vent tool and vent tool extender. This will be used to vent the 10 pounds of ammonia that's currently inside the pump module. Now, the reason we have this tool is to protect the crew from the actual venting that takes place and from the ammonia. So you can see this end is going to attach to the pump module. And once it's attached to the pump module, we'll have another end. This is called the vent tool. And then we'll have this end will attach to the vent tool extender. You can see the 2 pieces mate here. They'll be locked into place. And then we have approximately 15 feet total of length. And this will be the nozzle that's at the end that the ammonia will be vented from. And so this nozzle, we have the option of clocking it in many different directions in 30-degree increments with an EVA change-out mechanism, or ECOM fitting.